This video is going to go through the 4-1 warm-up and then the 4-2 notes. So if you haven't already, allow about 5 minutes for students to work on the warm-up, and then go ahead and unpause this video so that we can go over the answers, and then we'll start the notes on 4.2. All right, so number 1 on 4.1 warm-up says to find two coterminal angles, one positive and one negative. So remember, coterminal means I'm going all the way around the circle again. If it's in degrees, I'm going to take that degrees and add 360 to it. And I'd get 480 to get a positive coterminal angle. And then I would subtract 360 from it, negative 240, to get a negative coterminal angle. So positive 480, negative 240. Number 2 says to find the complement and the supplement of pi over 3. So the complement, we're going to do pi over 2 minus the angle, and the supplement pi minus the angle. So pi over 2 minus pi over 3. I have to change these so that they both have a like denominator, which would be 6. So this becomes 3 pi over 6, and times 2 here, and 2 pi over 6. And I end up with just pi over 6. So A, pi over 6. B is the supplement, so pi minus pi over 3 becomes 3 pi over 3 minus pi over 3, or 2 pi over 3. And there's your supplement. Number 3 says to convert the angle to radian measure. So if I'm going from degree to radians, I'm going to take theta, and I'm going to multiply it times pi over 180. So 150 times pi over 180. I can eliminate my zeros. 3 goes into both these 5 times and 6 times, and I get 5 pi over 6. And number 4 says a circle has a radius of 7 inches. Find the length of the arc intercepted by a central angle of 210 degrees. So remember here, we have to convert this into radians. So the equation here is S equals theta times the radius, but theta, which is this 210, has to be in radians. So I'm going to multiply times pi over 180, again, cross through my zeros, and again, 3 goes into both of this. This would be 7 pi over 6. Now I take that and multiply it times the radius, which is 7, and I get 49 pi over 6. And I have a unit here, it's inches. So the arc length is 49 pi over 6 inches. Okay, so now we're going to get into the notes for section 2 in chapter 4, which is called the unit circle. This is your unit circle. So the unit circle is a circle that has a radius of 1. So I'd start at 0 with a center at 0, 0. If I'd start at 0, 0, and I go right 1, and I go up 1, and I go left 1, and I go down 1, I create what's called the unit circle. So again, radius here being 1. So eventually you should be able to fill this entire thing out on your own. If this is I and J, we did it yesterday. If it's C period, I'm going to do it with you tomorrow. But these all have important components. So the inner ring is each of these angles in degrees. It starts from 0 and it goes all the way back to 360. Next to those are my radian degrees. So if I had converted each of those radians, each of those angles from degrees to radians, I would have gotten all of those purple angles. And then the outer ring are the coordinates of the points at the end of those angles. So we talked about, again, in I and J, we talked about every over 6 has that root 3 over 2 and 1/2. Every over 4 has that root 2 over 2 and root 2 over 2. Every over 3 has that 1/2 and root 3 over 2. And shortly we're going to learn why all of that's important. So this is where that unit circle comes from. The length of the arc intercepted is t. It's also the radian measure of the central angle, and that's why it's a unit circle. So for each point on my unit circle, that's at the end of my angle, like here or here, okay, we call this central angle T. Here's the arc length, and this point here is what we're going to use, or here, okay? okay, to determine the values as we move around the circle. These are your 6 trig functions. So the 3 that you know the most probably are sine, cosine, and tangent. So on the left is the full word, on the right is the abbreviation we use. And those reciprocal functions, so the reciprocal of sine is cosecant, abbreviation is CSC. The reciprocal of cosine is secant, abbreviation SEC. And the reciprocal of tangent, cotangent, reciprocal, and the abbreviation is COT. So why is this, or how does this tie into those coordinate points? If I have an x and y coordinate point at the edge of my angle, then the sine is the y coordinate, the cosine is the x, the tangent is the y over x, and then comes the reciprocal functions. If I flip sine, I'd get cosecant, so 1 over y, or the reciprocal of sine. Secant is the reciprocal of cosine, or 1 over x, and cotangent is the reciprocal of tangent, or x over y. Notice that these all say where the denominator cannot equal 0, because then it would make it undefined. So if it asks for the coordinate point and then it asks you for a sine or cosine or tangent in which your variable on the bottom is 0, if the number on the bottom is 0, then obviously that it would be undefined at that point. So example 1 says to use the figure at the right to find the trig function at t. So there are 6 trig functions: sine, cosine, tangent, and we find them of angle t. So sine of angle t, cosine of angle t, and tangent of angle t. Then cosecant of t, secant of t, and cotangent of t. Oh, there. So we said sine was the y value. So if this is my coordinate point, then the y value is root 3 over 2. The cosine is the x value, which would be 1/2. The tangent is the y over the x. So root 3 over 2 divided by 1/2. Keep change, flip, and it's root 3 over 2 times 2 over 1, which becomes just root 3. Now the reciprocal functions. So for cosecant, I'm going to take my sign and flip it. It would be 2 over root 3, and we get to rationalize it. So multiply both the top and the bottom by the square root of 3, 2 root 3 over 3. The secant is the reciprocal of the cosine. So I get 2 over 1, or 2. And the cotangent can either be x over y, 1/2 over root 3 over 2, or the reciprocal of tangent, which would be 1 over root 3. And then we rationalize it, and I get root 3 over 3. So my 6 trig functions based on this angle here, which hopefully we remember, especially if you're in I and J, that if it's a 1/2 root 3 over 2, this is actually at pi over 3. That's the angle that's there, or 60 degrees. Example 2 takes it one step further. Now it says find the point xy on the unit circle that corresponds to the real number t. So if t is my angle and it's saying 2 pi over 3. Now if we've learned our unit circle, which we know looks like this, and we locate 2 pi over 3, which is here, I'm going to get that coordinate point is negative 1/2 and root 3 over 2. Now let's say we don't know the unit circle that well yet. We should know that any over 3 is 1/2 and root 3 over 2. And if I want to know where 2 pi over 3 is located, I know it's bigger than a 1/2 pi, which would be at my 90-degree angle, but less than 1 pi, which means it's in the second quadrant. And in the second quadrant, my x is negative and my y is positive. So now I know that coordinate point would be negative 1/2 and positive root 3 over 2. Now take that even one step further and find the coordinate point, then find the sine, the cosine, and the tangent of that coordinate point. So we just did 2 pi over 3. We said this was negative 1/2 and root 3 over 2. So my sine is the y value, root 3 over 2. My cosine is the x value, negative 1/2. and the tangent is root 3 over 2 over negative 1/2, or root 3 over 2 times a negative 2, which is negative root 3. B is our first negative angle, so it says negative pi over 3. Now remember that negatives go in the opposite direction. So normally pi over 3 is up here in my first quadrant. There's two ways to look at a negative angle. Either go the same distance but clockwise, so it would be down here in that fourth quadrant, or go to where it's positive and then fold your graph at the x-axis, and wherever it overlaps, which would be down here, is the negative version of that angle. So again, we know an over 3 is a 1/2 and a root 3 over 2. And because it's a negative, it means it's in this fourth quadrant. And in the fourth quadrant, my x is positive, my y is negative. Now I can identify my sine as my y, which is negative root 3 over 2. My cosine as my x, positive 1/2. And my tangent as negative root 3 over 2 over 1/2, keep, change, flip, and I get negative root 3. Sine, cosine, tangent. Okay, now comes C, 6 pi over 3. So this one is different from what we've dealt with before because we can actually reduce 6 pi over 3 into 2 pi. So think about my unit circle. 2 pi is over here, and 2 pi has the coordinate point 1, 0. So my sine is the y, which is 0. My cosine is the x, which is 1. And my tangent is the y over the x, which would be 0. So tangent 0, cosine 1, sine 0. Okay, we're actually going to stop today, and you're going to make sure you submit these notes. And then use the remaining time to work on the 4.2 homework. You can actually complete questions 1 through 6 based on what we covered today. A lot of them have multiple parts, just like the ones that we did, so make sure you give yourself a little bit of time to work on that. Again, you can complete 1 through 6 today, and then we'll pick up with the rest of it tomorrow. Have a great day, guys.